This video is going to go over the different kinds of lines and well, things related to lines. So we're going to look at it real quick again because I know it's been a little.
Point, a point, dot, or a dot.
Okay, so the first thing we're talking about is a point, and I want you to look at her hand, curled up into a little ball. A point in math will usually look like a dot, or just be a circle on the page.
Ray reminds me.
Okay, remember the ray has a part where it starts from. In this case, like her arm starts at her shoulder, but her fingers, her hands are reaching out because a ray doesn't stop. It has a point where it starts, or what they call an end point, but then the other side goes on and on forever. It keeps going and going and going. In math, that'll usually look like an arrow. So because they don't have people with their arms and they can't show that their fingers are reaching, they'll usually draw an arrow at the end to let you know that it's going to keep going and going and going.
Rays with just one point.
Okay, the angle is when you have two rays. So we can see one ray here. Fingers are reaching, they're going on forever. Another ray, again, fingers are reaching, going on and on forever. But they meet here at the vertex, which here would be like her shoulders.
Just one point. Line. Way to remember.
Okay, a line. One straight line, and if you look, both hands have their fingers out. They're reaching, they're stretching. Because a line in math goes on and on forever, does not stop. Again, because we don't have printers that go on and on forever or paper that goes on and on forever, we put arrow on both sides to show that the line keeps going and going and going both directions.
Segment is another line.
Okay, a line segment. A line segment is like a short piece of a line. It's not the whole thing. It's like if you took a line and you just cut a part out. Because instead of having those arrows, instead of having a line that goes on and on forever and ever, you have one part where it starts and one part where it stops.
To line.
Okay. Parallel, you need two lines to have parallel. You have two lines. If you look at her arms, even if we stretched her arms out, stretched them forever and ever, both ways, they wouldn't touch, they wouldn't run into each other. That's what parallel lines are. Parallel lines never run into each other, they never touch, no matter how long you make the line.
Lines cross.
Okay, perpendicular. They are lines that cross, they have to cross. And when they do, it looks like a capital letter T. Perpendicular lines cross, they always make right angles. If you look at the capital letter T, or if you look at her hands here, if you were to put a sticky note here in the corner in the vertex, it would make a perfect right angle. Perpendicular lines always make right angles.
A vertex where two rays meet.
Remember, vertex in math, that's just a way to say the corner. So when you have two rays, wherever they touch, wherever they run into each other, that's your vertex, your corner. Okay, we can go ahead and turn our cameras back on. And we're going to take a look at this page here. And we're going to try to define or give examples of these different terms for math. Okay. Term number 1. It says blank. A line that has only one endpoint. So a line that has only one endpoint, which means that one side stops, but the other side goes on and on forever. What kind of line was the one that stops on one side and goes on and on forever and ever on the other side? What do we call that? Kind of line that stops on one side, goes on and on forever and ever on the other side. Heading?
Pyramids?
Okay, sorry, try again. Not parallel, because remember, for parallel I need two. I only have one line here. If it has one point where it stops and one side that goes on and on forever, what was it? It started with an R. Alexa, do you remember? Not an angle, because I don't have the other line to make the angle. This was just a line by itself. We're not playing with the camera, Nakai. What if I did this? What if I drew the sun? And out of the sun, I drew all these lines. Can you say again, Haydeen? If I drew the sun and I drew all these lines coming out of the sun, all of them have an endpoint, but then they keep going forever and ever. What do we call those little pieces of light? Sun. Chase? What do we call those? Solar flare. No, no, that's something a little bit different, but very good. Glad you know about that. Sometimes people call you this when you're being really happy and cheerful. When you're really happy and cheerful, you're smiling a lot. They say, "Aren't you a blank of sunshine?" Kylie? Array. That's what we call this. R-A-Y. So this is array. It has one side where it stops, and the other side goes on and on and on forever. We call that array. All right. The next one says two rays with a common endpoint. Okay, so now we need two rays. Here's one ray. And if it says with a common endpoint, that means they both share the same endpoint. So the other ray can this. What do we call this? We have two rays that share the same endpoint. Kylie, what do you think we call this? Okay. Who thinks they know? This one starts with an A. What do we call this when we have two rays that touch? Chase, what do you think? Something with an A. Ah, okay. Very good guess. Not acute. Not always. Sometimes it's acute, sometimes it's right, sometimes it's obtuse, but they're all kinds of what? Jaylene? Awesome. They're all kinds of angles. So when you have two rays that have a common endpoint that touch, you have an angle. And sometimes it's going to make an acute angle, sometimes it's going to make a right angle, sometimes it'll make an obtuse angle, but it will always be an angle. That was a very good guess, Chase. All right, next one. A set of points that extend in opposite direction without end. So when you have them going on and on, forever and ever, they never ever stop. They go both directions, backwards and forwards, forever and ever and ever and ever. What do we call that? When it goes on and on, forever and ever, both sides, backwards and forwards. This was one that starts with an L. What do we call that thing with an L that goes on and on, forever and ever? Jaylene? Okay, who can tell me? What's that thing with an L that goes on and on, forever and ever? Violet? Not lateral. So something with an L, so you had the L part right. And it goes on and on, forever and ever. Not quite a long word is lateral, it's shorter than that. Something with an L that goes on and on forever, both sides. Who can raise their hand and tell me, what do they think it's called? Irene? I need two. I only have one here. What is it called? And it's just one. Jaylene, think you got it? Line, thank you. This one is called a line. A line has to go on and on, forever and ever, on both sides. So neither side stops. Both of them get arrows because it goes on and on, forever and ever. Of course, I don't want to sit here and draw forever and ever, so I put arrows to show. Oh, okay, we were just working with these. A triangle with one obtuse angle. So if I have a triangle and one of the angles is obtuse, what would I call that triangle? What kind of triangle is it? Kylie? An obtuse triangle. I'm going to write underneath the line because I don't have enough space there. Obtuse triangle. Very good. Right? 5 says a triangle with 3 acute angles. So this time they want 3 angles, not just one, 3 angles that are acute. What do I call that kind of triangle? Triangle with 3 acute angles. Chase? What is it called, Chase, when it has three acute angles? An acute triangle. Very good. And again, I'm going to write underneath the line 2 so I have the room. Sebastian, make sure you're following along, sir. Move my paper up a little bit. An angle that forms a square corner. So if I have an angle, and if that angle looks like the corner of a square or the corner of a sticky note, what do I have there? Heading? A right angle. I'm going to write under the line again. Right angle. The next one says a line that has two endpoints. Okay, so this is like a line, but instead of having arrows on both sides, it has endpoints where it stops. Who remembers what was this called? Not a whole line. It's just a part. Something with an S. We call this a line what? Jaylene? Not a spot. Because a spot would just be like one point by itself. But this is a part of a line, but it's like if I took a line and I just cut a piece out, chopped it up. A line what? Something with an S. Line. And this word's a little trickier. Alexa? Not singular. It's not singular. Violet? No, not a point. Because that would just be one dot by itself. Points make up a line. You're getting closer. So this one we call a line segment. A line segment. Again, that's like if you took a line and you just...
You forgot.
Well, you can either call it a segment or a line segment, but you're right. I can fix that. Line segment. And that's just if you took a line and you just chopped out a piece. Our next one is lines that cross at a right angle. Well, If they cross at a right angle, it would look something like this. I'd have one line here, and the other line would go here. It would go on and on. This one had a longer name. Started with a P. Jaylene? Very, very good. These are perpendicular lines. Actually, you know what? I'm going to write it below the line so that I know that I have enough. I don't think I'm going to have enough room if I write it on the line. Perpendicular lines. And those are the ones that when they cross, they make right angles. And it looks kind of like a capital letter T, or even a lowercase letter T, or an X. They're on its side. Number 9 says an angle greater than a right angle. So if I took a right angle and I stretched it out and I made it bigger, what do I call that? I took an angle and I stretched it out till it was bigger than a right angle. What kind of angle is that? Violet? That's an obtuse angle. Sebastian, do you have all this written down? So it's all on your paper already? Okay, make sure it's on there. Yes, Kaylee. That's alright, baby. Make sure it's plugged in for now, but then I'll go ahead and move the paper up to show you the ones that you missed, okay? So catch up on what you can see for right now. Okay, Brianna. Problem 10 says a point where two rays meet. So when I have two rays, right here, where they actually touch or run into each other, what do we call that in math? Where the two rays meet. What do we call it? Aileen, what do we call that? Awesome, a vertex. So if it wasn't math, we'd probably call it a corner. But for math, the word they like to use is vertex. And if I look at that first letter, vertex, V, it shows me a pretty good example of what a vertex looks like. Okay, maybe I'm going to move it down a little bit for you. That way you can see. So we're going to continue on with question 11. Look at the figures shown. So we have 4 different figures. Draw a circle around the line segment. So we have figure 1, figure 2, figure 3, figure 4. Who can tell me which one of the figures shows us a line segment? Which one shows a line segment? Haley. Okay, number 3. If I look at number 3, it's got arrows on both sides. Line segments, remember, are those parts of the lines like if you chop them up and you just have a little piece of them. So those don't go on and on forever. So what's the figure that shows me a line segment? Like if I took a line and just chopped a piece out, where it stops on both sides. Jaylene? Number 2, because if I look at the ends, both of them just stop. They have a point at the end. I'm going to circle number 2. That's my line segment that stops on both sides. Draw a square around the ray. So a ray was where one side stops and the other side keeps going. The other side keeps going on and on forever and ever and ever. The opposite side stops. Which figure shows me one side that stops and one side that goes on and on forever and ever? Alexa? Figure 1. So I'm going to put a square around it. Okay. Draw a triangle around the point. So a point is just like one dot on its own. Poor lonely dot. Who can tell me which figure shows me a point? Ezekiel. Which figure shows me a point? What do you think? Figure 1, figure 2, figure 3, or figure 4? Which one shows me a point? Four, perfect. I'm going to put a triangle around figure 4. The last one, draw a rectangle around the line. The lines have to go on forever and ever, both directions. Alexa, which figure shows me a line? Figure 3. I'm going to put a rectangle around figure 3. Okay. Question 12. Let me move my camera down a little bit. Heidi draws 2 lines on her paper. The lines intersect and form 4 equal angles. Which term can be used to name what Heidi drew? Okay. Well, let's see if we can copy what Heidi did. 2 lines. Okay. 2 lines. And it says that they intersect, which means that they're going to run into each other. They're going to touch. And they make 4 equal angles. So all the angles have to be the same. Okay, Kylie. So there, all the angles are the same. Well, if I do that, my lines kind of look like like a lowercase t. They want us to tell them what kind of lines does she have here. Line segments, parallel lines, obtuse angles, or perpendicular lines. What kinds of lines does she have here? Jaylene, what kind of lines does she have here? These are perpendicular, because if I take a close look at these angles she made, they are all right angles. So they'd be perpendicular lines. They can't be parallel lines because parallel lines never ever touch. Since I see them crossing right here, there's no way for them to be parallel. Okay. "13 says Zaina drew a right triangle with 2 equal angles." Sure. Zaina drew a right triangle with 2 equal angles. Which term could also describe Zaina's triangle? Okay, so right triangle, 2 equal angles. Now remember, every single triangle, no matter what, is going to have 2 acute angles. So that makes sense. But they tell us it's a right triangle. So I know that one of them has to be a right angle. I'm going to make a right angle. And then I'm going to connect the 2 ends. So I have a right triangle. And I know that one of the angles is right. And I know that the other 2 are acute. And it says which one of these describes her triangle. Do we stay focused, Kaylee? Is this an acute triangle? Can this be an acute triangle? If one of the angles is right? Who can tell me, can an acute triangle have a right angle? What do you think, Bella? Can an acute triangle have a right angle? An acute triangle can have a right angle? Remember, an acute triangle has to have 3 right, or sorry, not right, 3 acute angles. So I have 1 acute angle, I have 2 acute angles, I don't have 3. If it doesn't have 3 acute angles, it can't be an acute triangle. So, not answer choice A. B. Can this be a right triangle? Chase, can this be a right triangle? Yes, it can. And remember, a right triangle only needs 1 right angle. Only 1. Oh, and look, it tells us that. Right triangle because there is one 90-degree angle. Remember, right angles are always 90 degrees. Okay. Why are we playing with the camera, sir? Let's stay focused on our work, okay? C. Obtuse triangle. Can this be an obtuse triangle? What do you think, Nakai? Can this be an obtuse triangle?
Yes. Maybe.
Well, it's a yes or a no? What do you think?
Yeah.
So, Nakai, do I see any obtuse angles? So, can it be an obtuse triangle if there's no obtuse angles?
No.
No. An obtuse triangle needs one obtuse angle. But I have an acute, another acute, and a right angle. So this can't be an obtuse triangle. Yes, Kylie? It's okay, I'll go back for you a little bit later, okay? D. Can this be a right triangle? Alexa, what do you think? Could this be a right triangle? It can't be a right triangle? Yeah, it's got a right angle. So it could be right triangle because there are two 90-degree angles. Alexa, do I see two right angles? No. So it is a right triangle, but it can't have two right angles. It can only have one. So answer choice B is my answer. We'll do one last question, question 14. Which best describes angle JKL? JKL. Choose my sticky note. Match the vertexes and see what kind of angle we have. All right. One of the lines is perfect. One of the lines is covered up. What kind of angle do we have if one of the lines is perfect and the other's covered up? We call that what kind of angle? Irene? An acute angle. So Heidine, help me out with my answer choices. F. Can it be a right angle? What about G, an obtuse angle? What about H, an acute angle? Maybe. What about J, a straight angle? No, it's not straight. You're right. It's got a bend to it. There is such a thing as a straight angle, but straight angles look like a straight line. They look like that. And this line does not look like a straight line. Yeah, it's almost shaped like a capital letter A. This is an acute angle.